Good morning, good afternoon, good evening. Wherever you are watching this channel, let me welcome you all to our channel Future Endeavors. So, in the previous class, we have been discussing about the refraction at plane surfaces. We have discussed or learned about what refraction is and some related topics to refraction. Okay. So, we have also learned about incident ray, refracted ray, what is angle of incidence, what is angle of refraction. We have learned about all these things. Now, today we will be mainly discussing about the laws of refraction. So what are the two laws of refraction, and correspondingly we will be discussing about the refractive index of a medium. Okay, so without wasting much time, let us quickly move on to the topic. So first of all, let me write down the heading. So it's laws of refraction. So you have already learned about the laws of reflection, isn't it? You have learned about the laws of reflection. So what are the laws of refraction then? Now, as you have learned in case of reflection, first law states that the incident ray, the reflected ray and the normal at the point of incidence are lying in the same plane. Much is the same case for refraction also. The incident ray, the refracted ray and the normal at the point of incidence basically lie in the same plane. So just note it down. First law states that the refracted ray and normal at the point of incidence. Normal at point of incidence all lie in same plane. All lie in same plane. Now, let me be clear about this point. Many of you get confused about the plane. Actually, which plane we are talking of? The same plane. What does that mean? So, for this, just let us take an example. Consider that this is considered a book. So let us consider a book. Okay. So consider this is a book. Okay, and the light, incident light, is falling on the surface like this. This is the refracting surface. Means this is the plane which is separating the medium, two mediums. Okay, so light is coming from this direction. It gets refracted and it emerges out from below. So the below is a different medium, above this book is a different medium. So say air to water. Now when you are talking of the same plane, actually this plane is not referred here. Remember, the plane that you are referring here, say if the light is coming like this, okay, light is coming like this, and then the refracted ray gets like this, okay. So this plane, this board, this white board along which the light ray is coming and the light ray is getting refracted, we are talking of that plane. So when we are saying that all these incident ray, refracted ray and the normal at the point of incidence lie in the same plane, what we actually mean by the same plane? So I think the concept is clear. The plane here is actually this plane whiteboard. Okay, if I consider this hand is my is the surface separating the two medium, and at this hand surface the refraction takes place. So the plane here is the plane of the board, not the plane of the hand. Okay, so this is the first law. The incident ray, refracted ray, normal at the point of incidence all lie in the same plane. Okay, so I think the concept is clear. Now the second point, coming to the second law. What does the second law say that? So for a particular reflection, say the second law says that the ratio of sine of angle of incidence. So if we take sinusoidal value of the angle of incidence, I think all you have learned in trigonometry about the sine value. So if we take the ratio of the sine of the angle of incidence to the sine of angle of refraction, this ratio is a constant. Refraction is constant. Now when it is constant? When you are considering the same medium. Okay, you have to consider the same medium. In that case, it will be a constant. Is constant for a particular pair of media. We have said that media is the plural form of medium. So for a pair of media, so this is a constant, okay, but remember this is constant only for a given pair of media. Say if we consider that we have air and water, for that the refractive index, sorry, I have not said what is refractive index, just let me write it down. So this ratio is actually, so I have said that this ratio is a constant, so you can also say that this constant is known by a different name and it is called the refractive index. So if I consider the sine of the angle of I to the sine of the angle of R, okay, so this ratio is a constant for a given pair of medium, as I have said, okay, constant, and this constant is called the refractive index. Refractive index, in short we denote it as Ri, okay. So in the next discussions, or when we will be talking about refractive index, we will be denoting it by the letter Ri. So this refractive index, this ratio is constant only for a given pair of medium. So if I am considering air and water, for that case we have a certain value of refractive index, and if I consider water is there, but if you consider instead of air glass water pair, so in that case the refractive index, value of the refractive index changes, okay. So this is a constant, this ratio is constant only for a particular pair of medium. Remember this thing, that is constant for a particular pair of medium, okay, particular pair of medium. When the medium changes, the value also changes, okay. So these are the two laws of refraction, okay. So now so I think you have learned the about a new physical quantity, refractive index, and this actually denotes that how much light will be deviated in that particular medium. The more the value of refractive index for a particular medium, the more is the deviation or diffraction produced in that medium. Rather I can say that the mediums having more optical density have greater refractive index, and the medium having lesser refractive index have lesser optical density, okay. So just let me elaborate it with a diagram so it will be easier to understand, okay. When I am saying that sin I by sin is a constant, just let me elaborate it here. So if I take two medium, okay, take two medium, it may be, we are denoting it as medium 1 and medium 2, consider two medium, okay. This is the surface separating the two medium, fine, and the light ray is coming like this, so it's falling on the light on the surface like this. Here is the point of incidence, and we draw a normal at the point of incidence, and say this is medium 1 and this is medium 2. The optical density of medium 2 is say greater than medium 1, so then obviously what will happen? I think you can answer that the light will bend towards the normal, isn't it? So this is the main fact, you know, that when light is actually moving from a rarer to denser medium, it actually bends towards the normal, isn't it? So I think all of you have remembered the facts and have been able to answer my question, okay. So in this case, if I consider this is the angle of incidence I and this is the angle of refraction R, isn't it? So for this, so I can say that the ratio of the angle of incidence and angle of refraction is a constant, or say rather you can say this constant is actually called the refractive index, okay. This constant is actually called what it is called the refractive index, fine. So this is the main law of the refraction. Now this law is also called the Snail's law. What it is called? It is also called the Snail's law, okay. So this is also known as Snail's law, okay. So this is also known as the Snail's law, fine. So remember this law is a very important law for refraction. Sin I by sin R is a constant value for given pair of medium, okay. So this is the second law of refraction, okay. Now you have learned here the refractive index. We can actually refer this refractive index as relative refractive index. Why? We can refer this relative refractive index as relative. Why relative? See, if I consider that the refraction is taking place from medium 1 to 2, now if you keep the medium 2, say the medium 2 is say glass and medium 1 is air for the first case. Now if I just think that if I consider that the first medium is not air, so actually what we are getting here, for this particular case, we are getting the refractive index. We write it like this: refractive index denoted by the letter mu, okay, or often it is given as the letter eta, okay. So mu here we write it as refractive index of the second medium, mu of 2 with respect to 1. We write it like this. We say it like this, that it is the refractive index of the second medium with respect to the first medium, and it is given as sin I by sin R. So I think you are able to capture this concept, that it is the refractive index of the second medium with respect to the first medium. Now say that if I just change the first medium, instead of taking air, if I just take the first medium as say water. So instead of air, what we are taking it as water, okay. So the refractive index of glass will now not be the same. Consider, okay, say if I consider the refractive index of glass with respect to air, it will have some value. When I am considering the refractive index of glass with respect to water, the value gets changed. So actually what I am trying to say, that you change the medium 1 and correspondingly the refractive index of the medium 2 changes, as because Snail's law said that these values are constant for a particular pair of medium. The medium changes, the pair changes, the value changes. So this is actually relative refractive index denoted by the letter mu and written as mu 2 with respect to 1. Now that is another refractive index, another formula for refractive index. We call it the absolute refractive index. So what is absolute refractive index? See. So that is another formula for refractive index. So it can be, refractive index can be also defined as the ratio of the speed of light in air or vacuum by speed of light in that particular medium. So another formula for refractive index Ri is given as the speed of light in vacuum, okay, to the speed of light in that medium, speed of light in that medium. So speed of light in vacuum is given by the letter C, and speed of light in that particular medium is given by the letter V. So it can be also defined as this ratio, refractive index, and here it is denoted by the letter mu only. So mu of that particular medium, mu m, okay, mu m, as because here the refractive index value does not change, and this is called the absolute refractive index. What is called? This is called the absolute refractive index. This is absolute. Why absolute? As because you know speed of light in air does not change. So we are comparing the speed of light of that particular medium with the speed of light in vacuum or air, which does not change. So this value is constant for a particular medium. So this is the absolute refractive index of a particular medium. So I think the concept of absolute refractive index and relative refractive index are clear. Okay, fine. Now, when I am talking that, if I consider the relation between absolute refractive index and relative refractive index, so when we are saying the refractive index of medium 2 with respect to 1, we can also write it like this. Just let me not rub it out. Medium 2 with respect to 1. This can be also written as absolute refractive index of medium 1 to absolute refractive index of medium. It should be medium 2 by medium 1. Okay. So this is the how we can actually express relative refractive index in terms of absolute refractive index. So I think clear the refractive index of medium 2 with respect to 1. So this can be written as C by V2 and C by V1. So C cancels out and this is given as V1 by V2. So relative refractive index can also be stated as the ratio of the ratio of the speed of the light in the first medium to the speed of the light in the second medium. So this can be also stated. So this is another formula for the relative refractive index, V1 by V2, when light is traveling from medium 1 to medium 2, or you can say relative refractive index of medium 2 with respect to 1. So this is relative refractive index in terms of the speed of light. Okay. So I think the concepts are clear. Fine. So remember these formulas. These are very important formulas and important concepts. So please, if you have not understood the concepts, please just rewind it once again and see it in a bit slow motion. I think you will be able to understand it. Okay. So these are the values of the refractive index. Fine. Now let us quickly move on to the next topic. So I think this concept is clear. Let us quickly move on to. Okay. So the next topic that we are going to talk about is principle of reversibility. Principle of reversibility. Okay, so what does this say? consider when I am talking about the refraction of light, say from medium 1 to medium 2. This is medium. This is a plane separating the two medium. The light comes from this surface. We are drawing a normal at the point of incidence, and the refracted ray goes like this. Okay. So if I consider this as the case, so this is medium 1 and this is medium 2. So this is the angle of refraction R and this is the angle of incidence I. Fine. Now when I am saying that light is coming from medium 1 to 2, we say that refractive index of medium 2 with respect to 1 is equal to sin I by sin I. Now just think of the reverse case, when the light is actually going in the other direction, that is, it is coming from the medium 2 and then getting refracted in medium 1. So thus the path is reversed, and actually the light follows the same path, just direction is reversed. So in this case, can you say, now we will be talking of refractive index of medium 1 with respect to 2, isn't it? So this will be refractive index of medium 1 with respect to 2, and this will be now equal to sin R by sin I, isn't it? So considering these two cases or these two equations, can we write that refractive index of medium 2 with respect to 1? So we can easily write that refractive index of medium 2 with respect to 1 is the reciprocal of refractive index of medium 1 with respect to 2. So this is the principle of reversibility. Okay, so note it down. This is the principle of reversibility. So mu of 2 with respect to 1 is equals to mu of 1 with respect to 2. 1 by 1 with respect to 2. So this is reciprocal. So this is the principle of reversibility. So I think the concept of principle of reversibility is clear. The light will follow the same path, just it will go back in the reverse direction. Fine. Now let us quickly move on to the last topic of today's class, that is lateral displacement. Okay. So what is lateral displacement? Consider a thick glass slab. Okay. So consider a thick glass slab. What happens in a thick glass slab? When light passes through a thick glass slab, what actually happens? Refraction, obviously refraction will take place. You can easily understand. So lateral displacement. So what is lateral displacement? Okay. So what is lateral displacement? Say this is a thick glass slab, as you can see in paperweights or any other thick glass slab. So when light is coming onto this surface, just consider this thick glass slab. Okay, light is coming onto this surface. Now what happens here? If I just draw the normal at the point of incidence, the light ray would actually be going in this direction had the glass slab been not placed in its path, isn't it? That is the fact. Okay. Now it will at this end it will be refracted and it will bend towards the normal. So it will be bending like this towards the normal, isn't it? Again, if we draw a normal at this point of incidence, so just let us draw a normal at this point of incidence. So another normal at the point of incidence. Now the light will again coming out from the glass to air, so it will bend away from the normal and hence it will go like this. So actually what I am trying to say is that had the glass slab been not placed here, the light would have gone in the direction as shown by the dotted line. But due to the glass slab, the light is passing actually parallel to the actual path of the incident light, but slightly displaced, parallelly displaced. So this distance, this gap, this perpendicular gap is called the lateral displacement. Okay, so I think the concept is clear. And here one thing you have to know, that this is the angle of incidence, this one is an angle of refraction, so this will be the angle of incidence will be same as that of R, and this is the angle of emergence E. For a parallel glass slab, what happens is that the angle of incidence is equal to the angle of emergence. This is called the angle of emergence. E is referred to as the angle of emergence. So for a parallel side thick glass slab, the angle of incidence is equal to the angle of emergence. So this is the lateral displacement. So I think this concept is clear. Okay. So with this, today we will be ending our lecture here. In the next class, we will be moving on to the next part of this chapter. Okay, so till then, please do study well. If you have any problem or query, please do mention it in the comment box. We're happy to solve your problems, and thank you for supporting us. So till the next video, thank you, goodbye.